to room 109 on a Sunday morning. The links I'll go to for you stats students. Okay, so I'm going to look at problems 6, 7, 8, and 9 in this short video. I hope it's fairly short. So I'll read through these problems and give you the correct answer on these. So the first one says, which of the following statements is not true? Careful of those nots. Of the correlation R between the lengths in inches and the weight in pounds of a sample of brook trout. R must take a value between -1 and 1. That is true. R is measured in inches. If longer trout tend to also be heavier, then R is greater than 0. Yeah, that's going to give us a positive slope, so that is also true. Not too sure about B, I don't like that one. R would not change if we measured the lengths of the trout in centimeters instead of inches. That's true, that's not going to change anything. And R would not change if we measured the weights of the trout in kilograms instead of pounds. So everything here is true except B. R is correlation. It's simply how spread out the data is. It is unitless. Standard deviation has units, but R is unitless. So B is the correct answer here for that one. Number 7, this one's a little tricky. When we standardize the values of a variable, the distribution of standardized values has a mean of 0 and a standard deviation of 1. That's exactly what standardizing does. Suppose we measure two variables, x and y, on each of several subjects. We standardize both variables and then compute the least squares regression line. Suppose the slope of the least squares regression line is -0.44. We may conclude, okay, remember B equals R times S sub y over S sub x. The kicker in this one is that it says that the standard deviation is 1. So, since that is 1, and we get 0.44, or -0.44, what must R be? Well, R must be -0.44. And that is E for the correct answer. The correlation will also be -0.44, simply because of this one situation. That's tricky, but that's where that answer lies. Okay. Number 8. There's a linear relationship between the number of chirps made by the striped ground cricket and the air temperature. A least squares fit of some data collected by a biologist gives the model y hat equals 25.2 plus 3.3x, where x is the number of chirps per minute and y hat is the estimated temperature in degrees Fahrenheit. What is the predicted increase in temperature for an increase of 5 chirps per minute? Let's see, where x is the number of chirps. Okay, so x is the number of chirps. So what we can do, there's a couple ways to get this done. There's sort of the short, easy way, or there's the longer way. The longer way might be simply to plug in some values here and say, okay, what if we get 0 chirps per minute and then 5 chirps? And we find those y hat values and we subtract them and we get an answer. But the shorter way to do this is all you really need is the slope and the x value. That kind of gets this done. And you can pick any numbers here as long as they're 5 apart to make this work. But really all you need is, and I think I've already done it here, but I'll do it, 5 times 3.3, 5 chirps times the slope, and we get 16.5, which is exactly the difference you'll get if you pick two values and subtract the answers. So either way works. All right, number 9. The scatter plot shows the relationship between the number of people per television set and the number of people per physician for 40 countries. Along with the least squares regression line, In Ethiopia, there were 503 people per TV set and 36,660 people per doctor. Which of the following is correct? So, looking at this, it looks like this guy right here is Ethiopia, about 503 people per TV set. So, here's how many people per doctor we expect. It looks like it would be about 15,000 would be our Y hat value, but they're at like 36,000, almost 37,000. So I'm going to just read the answers and I'm going to leave the graph up here. It says increasing the number of TVs in a country will attract more doctors. Correlation does not suggest causation, so I think that one is out. The slope of the least squares regression line is less than 1. Well, that's not true because we have a positive slope here of the least squares regression line, so it's definitely not less than 1. Oh, hang on a second. The slope of the least squares regression line is less than 1. Oh, I see. No, that's not true. It's kind of tricky because this definitely has a look of a line that's less than 1, but because our numbers are not scaled the same, if our numbers were scaled the same, this would be a very steep line. The slope of the least squares regression line, hang on. C, the correlation is greater than 1. Correlation can't be greater than 1. So, no, that's false. D, the point for Ethiopia is decreasing the slope of the least squares regression line. I don't think a point up here is going to be decreasing the slope. It's actually going to be pulling the slope up higher than what it might naturally be. It's kind of an outlier, and it's dragging that mean that way, which in this case is the slope. And E, Ethiopia has more people per doctor than expected, based on how many people it has per TV. That's your true. We expect about 15,000 per doctor. We got about 37,000 per doctor. So E is our true statement. Anyway, on to the next video.